The first thing I want to tell you about Seymour, I'll call him Seymour, that's what I call him. The very first years of our doctoral seminar, and here we are at MIT, it's 1985, and the lab has just opened up, and everybody is very excited, and you know, we're with Seymour Papert, working in the Hennigan School. He says in the middle of doctoral seminar, "Ricky, go get your pink bike." So I think, okay, I get my bike, and he puts it right in the middle of the seminar room on the table, turning it upside down, of course. And we start talking about gears.
He was always looking for procedural hands-on activities for kids. When we started to teach kids logo, we thought what we would like to do in the classroom, not just learn to program, but to relate that to other activities. And the other activities were things like circus arts. So Seymour learned to ride a unicycle, so did I. We learned to juggle. We did bring a bongo board to the classroom, and there is a video of me pushing Seymour on the bongo board.
Learning is not possible. There is no learning without playing. And there is no learning, there is no playing without important end product for children.
The kid said, "Hey Seymour, I have this idea for a robot burning inside of my head. I can't stop thinking about it." A few days later, Seymour Papert drove to the halfway house where the kid was living, hours away from Seymour's home, rang the bell, and handed him a few $100s worth of Lego sets so he could realize the idea in his head.
He would listen to students, he would then retell their stories, he would listen to colleagues and really learn from them.
Seymour explained the difference between Euclidean point and line geometry and the turtle's idea of position and heading. And he showed something very simple and very beautiful. He showed how one of the classic circle theorems could be expressed completely differently using the turtle geometry.
Because you could use turtle geometry as a micro world to move the object of the turtle in a way that could represent geometry in a more dynamic way, in a more linear way, in a more body syntonic way, that made that piece of programming a tool for students to understand math more. In his vision, it was always those computational ideas were tools that he felt like the computer made it possible to give students to be able to learn all kinds of things in other ways.
I think maybe Papert was the first educator to anticipate the possibilities that would come from this, and having the turtle make drawings, sort of environment in which you could have procedures that actually produced something you could pass around and take home.
In synthesis, it seems that Seymour is one of the best thinkers that I ever met in my life, and not only developing ideas about powerful ideas, thinking about something and debugging, but he's able to put them in practice. And you can see that when you do that, you become a very powerful problem solver and a thinker and also a learner.
It is so exciting now to see that work with programming and teaching children to program, all learners to program in lots of different ways is becoming fashionable again, it's becoming exciting to people again. People just are doing a lot more work on it. It's almost the same kind of energy that it was when Logo first came out.
It wouldn't have been possible at all to do this without Seymour's attention to caring about children, and that each person, each student, each learner has to find their own path and create something that is meaningful for them, and thereby doing have something to offer others.